We're going to be using the Z-score tables for today's lesson. And it's going to be Z-scores for data that's normally distributed. So we're continuing on from yesterday's lesson using this connected to the Z-score. Look at the second picture. See that Z-score in general? That Z-score in general can be found with this formula. X is your particular data value that you care about. X is the value for that Z-score. Okay? So like on the example we just did, if I got like 57, and I want to find the Z-score for 57 in here, 57 would be my particular X value that I'm interested in. This symbol is mu, and it stands for the average. In our previous example, it would be 55. It's the middle value. Yeah. And then this O with a tail, standard deviation, not theta, but sigma. Sigma, yeah. So X minus mu, get that value, and then divide by sigma. There's little invisible brackets there. Make sure you subtract, hit enter, then divide. So, you see this capital A bracket Z? That just tells you that it's the area of the Z-score. You can jot that down or highlight it right here. A of Z is just the area of the Z-score. So for this particular Z-score, it's this area. Notice which way it's shaded. To the, just like Beyonce, to the left. So if you got this Z-score, you're better, or whatever it is, compared to all these. Okay? Let's say it's height. Can't really be better for height. Height is height. If you had a Z-score for height, this means that you're taller than most people for your statistical group. What if the Z-score was over here on the left side? Then you're shorter than most people in the statistical group. Okay? If you can get that, it's just punching in numbers after this. Okay, negative Z-score, you're below. Positive Z-score, you're above. Okay, that's pretty straightforward. Now, for the fourth bullet, the Z-score table, it gives you the area of the curve to the left. Or it gives you the percentage of data to the left. Or it gives the probability that a randomly chosen data value is to the left. So those three things are all going to represent the same thing. Area, percentage, probability. And like, where does this have application in our real lives? Like, think about insurance for cars. This is a good one. Young males especially who drive red cars. Now compare that to middle-aged females who drive minivans. Which of those groups would be more prone to having a car accident? The young males who drive a red car. So then when you go to buy insurance, exactly. But because you're a young male going to get insurance, you have to pay more for some reason. Because of the statistical analysis and the probability of becoming an accident. Becoming a statistic, you ever hear that? Don't become a statistic. This has huge applications in probability. And probability is used in mostly like insurance. Okay? And the mean, the median, and the mode will have the Z-score of 0. That, yeah. Yeah. Yeah, so that's a conditional probability, like a probability that changes the next probability. Yeah, that's called conditional. Yeah. That's like you have a deck of 52 cards, and it's like, what's the probability of pulling a particular card off? Pull a card off, and now don't put it back. It changes the probability for the next pull, right? We talk about that in 30-2 math. It's in there. Yep, it's a continuation. But good question. Okay, let's take a look at this. We got to figure out how to use our table. Okay, so focus on me. New skill. Find -3 on your graph. This would be -1. This would be -2. This would be -3. And which way do we shade? To the left. Is that a very big chunk that I shaded? So we are going to try to find in our chart a very small percentage that relates to -3. So now you got to flip. Okay, so she did it for us, but let's just go back, go find your chart. Okay, so you're looking at your chart. We're looking for -3, right? So here's -3. And then what's the decimal for -3? What's the second decimal? It was just -3, right? So the two decimals that follow are 0, 0. So they put the first decimal for you in the chart. They put the first decimal. But then for the accuracy, they put the second decimal vertically. So like if you wanted -3.09, it's that one. -3.08, it's that one. The one we want is right here, 3.00. So that's the one we want. Okay, so on the back of the book, the area was 0.0013. It's not up there. Okay. This is not the percentage. This is the area as a decimal. To get the percentage, you just got to slide the decimal, right? How many places? Is that okay for people? A very little amount, yeah. So look at your chart. Let's do an easy one. We'll look at your chart. Find the z-score for 0. Just do an easy one, just to make sure we got this. Find the z-score for 0. 0.5000. So what percentage is that? And then you'd slide the decimal, right? La, la. Okay, so just to follow along, we did another z-score, 0. And then we looked at our chart. The chart told us 0.5000. And then that means it's 50% of the data for that z-score. Which makes sense because 0 is right down the middle, right? You guys think you can handle the chart? Okay. I know. Okay. -2. 1 and 2. Okay, so I've shaded the regions for you. You basically place the z-score roughly where it is. Remember, below or above the 0. Negative 2 would be 2 ticks over to the left. And then you shade the region to the left. And then you go to your chart. And I'm not going to flip back and forth. I'm just going to use my chart. Go and find negative 2.00. Say that one more time, Carter. Just hands up, you need me to come see you quickly to help you find the 0.0228. You don't get this chart. Negative 2.0. And then because the second decimal is also O, not 1 or whatever, then you come find it here. Right there. Yeah, until you find the column. Okay. How come we're late? Uh-huh. Okay. Okay, looks like people are okay. Okay, so let's do the next one together. The Z score for the number 2 is 1.00. Okay? Do you see how it's Z score 1? Which means the decimal is 00. Okay, so let me go to the chart so that you guys can see it. Especially those that just got here. The Z score is 1.00. So that's the first 2 digits, but only the first decimal place. We need the second decimal place, which is another O. So it's right here. If it was 1.07, you'd have to go here. Get it now? Okay. Yeah, so on the left column, you have the 10th, and, pardon me, in the rows, you have the 10th, and then in the columns, you have the 100th. So like, let's just do one randomly. Let's do 0.95. Find that one. Z score of 0.95. We get the chart now? Okay, sweet. All right. Okay, so let's fill these out together. You guys could do them as well. For the 1.00, I got 0.8413. And for 2.00, 0.9772. Okay. So now we get to do these. 2.15 on the negative side. So it'll be roughly somewhere to the left. Negative 2.15. That's the Z score. And you shade to the left of that. Is that a very large area? No. So you're very much below average in this sense. What area for that z-score? Find negative 2.1 and then find the column with the 5. The area is 0.0158. Can everyone find that one? Now convert this to percentage. .58%. Yeah, for percent. Percent is out of 100. 100 is 2 factors of 10, 2 decimal moves. Now think about this percentage. Let's say you did an exam in this class and the data was normally distributed. If you scored 2.15 standard deviations below the average, you're only better than about 1.5% of the people who wrote the test. Okay? Let's try the next one. Also, look at the way that was shaded here. See how it says Z is less than this Z score? Look at the next one. What does that say? So we got to be careful with the next one. If this is negative 2.15, we have to shade the opposite section. See how this one's Z less than? The little pointy thing points to the Z, so Z less than. And then here, it's wide on the Z side, so Z greater than. We have to shade the opposite part of the region. So if it's 1.5% for this region, how would you get the rest of it? %, take away 1.58%. It's just the other part, right? If you drank 10% of your drink, what's left over? 90% of your drink, right? Do you need one of my guys? Say again. Ozzy? Do you mind just stepping out for a sec? Just right out here. Okay, guys, focus on me. Think about this for a sec. You scored 2 standard deviations below average. That means you beat about 1.5% of the people, but about 98.5% of the people did better than you. Does that make sense? Okay. All right. Now for the hard one. When it's squished between two values. This one's the hard one. And I'm going to have to use the whiteboard to explain this one. Okay. A less than Z less than B. Some of you might have had problems with this in Math 10C. You guys remember how you do like domain and stuff like this? What this means is Z is squished between A and B. It's bigger than A, but it's less than, it's squished between. Okay? Harley, can you come here, please? Just come here, Harley. I need your body. Stand up here. Ryan, can you come here? Okay, just stand there like this. Just so I can do height. Is Harley taller than me? You come here, come here. Come here. What about these three? These three gentlemen. So you need, see how Ryan has to come in the middle? Ryan is taller than this young man. but shorter than this young man. Make sense? He's squished between the two ends, the low end and the high end. Okay, thank you. Z is bigger than the low end, but higher than the big end. It's squished between. So how are we going to find the area like that? And then this one, you have to study, so this one's tough. So when you use the chart, listen to me guys, this is tough. Hey, when you use the chart and you find the area for 2.15, it gives you all that. Very good, Olivia, you're bang on. Now, for the negative 2.15, and you use the chart, you get that area, right? So how could you get the stuff in between? Good. So it's like area big, take away area small. It's the big area coming from this one. So it's the area of the 2.15, take away the area of the negative 2.15. Z-score. And that will give you the stuff in between. Okay, so area of the 2.15, oh gosh. Take away the area of the negative 2.15. I'm going to zoom in on this. The chart tells me 2.15, 0.9842. And for negative 2.15, 0.0158. Subtract those guys. So it's 96.84%. Of all the questions from this section, that's the one that will trip up most of you. Especially a couple days goes by and you forget to study and then there's an exam or something. This is the one that'll mess you up. This is the one that'll mess you up. So put a star on this one, study this one, make a note to your future dumber self. Because you got all different classes, you got teachers blah 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 at you, right? You're going to forget this stuff. Put some way to remind yourself. A big star, this one's tough. Okay, A and B, let's do these. Let's find 2.08. It's asking for us, again, help just with the basics. I want the Z-score, the area for the Z-score, less than 2.08. See, less than. The best part about the less than is that's exactly what the chart does. The chart tells us that. So that's the chart. Find 2.08. Find 2.0. 0.9812. And the percentage for that would be 98.12%. Yeah, for the percentage and decimal conversion, just 2 decimal slides. Okay, so the next one, 0.92. So just, you got to find the Z-score. Is the Z-score above 0 or below 0? Above 0. By how much? Not very much, right? Harley, don't click your phone right now. You're doing so well. Put that thing away. Now the chart will tell us to the left, but this one wants to the right. So what we want is 1 minus the area of 0.92. You remember if you drink 10% of your cup, you got 90% left? Okay. So in terms of percentage to decimal, 1, what's the percentage for 1? 100. So this is just 100% minus whatever the percent is for that one. Okay? So the 1 is just 100%. Because 1 is whole. Whole is full. 100%. What's the area for the z-score 0.92? 0.92. This is 0. I got 1212. Okay, so you have to do 1 minus that. Did you like it better when it was percentages? Choose your battles then. If it's easier for you in percentages, then this would be 100% minus 82%. 18%. Try to make it simpler on yourselves. If I drink 82% of my drink, what's left over? Yeah. Okay? Yeah, 1788, my bad. So I did the two questions, like one of them is in percent, one of them is in decimal, like you can do either, whatever you're comfortable with. Now this one's just nasty. Okay, so where's negative 1.75? I don't know, somewhere over here. Now where's negative 1.02? To the right of that or to the left of that? So we want this section. That's the section we want. Now to get it, you'll have to find the red, and then what do you have to subtract? Another color I'll use is green. What do you do with these two? You have to minus them. Try to imagine this with the color. The red is all the area to the left of the 1.02, right? The red is everything left of this one. And the green is everything left of this one. If I took those two areas and subtracted them, I would be left with just the black. Good. So red minus green equals the black. And now we can actually put in what those are. So how do you find the red one? Find the z-score for the 1.02. How do you find the green one? Find the area for this one. And that will equal what you want. So negative 1.02. And for the negative 1.75, so it's about 15%, take away 4% is about 11%. 0.1539, take away 0.0401, this is 0.1138. So question mark is a 0.1138, it's about 11%. So we'll spend a couple days on this, I think. We're definitely going to slow down here. So we got one more section to cover, these two. Okay, where does 1.83 live? And where's 2.65 live? Now we want the probability that you're going to fall in this region. Probabilities are values between 0 and 1. They're decimals. So like when you flip a coin, heads or tails, what's the probability you get tails? It's 50-50 in your everyday language, right? What decimal is for that? 0.50. Okay, 4-color spinner. Red, green, yellow, blue on a spinner. What's the probability that you spin a red? 25% is what decimal? 0.25. So probabilities are values between 0 and 1. So that's why this question wants you to just go to 4 decimal places. It just wants you to use that area value. Okay, and of course this is the same stuff, so we're in the middle. So we have to take the area for the big, and then we're going to subtract the area for the small. Which z-score will give you the big area? The 2.65, right? Because if you're 2.65, you're going to shade all this, right? But if you're 1.83 negative, you only shade this little guy. So it's the big, take off that little guy, and you're left with that chunk in the middle. Hopefully that makes sense. Okay, so the z-score for the 2.65. 2.65. On my chart, 0.996. Oh, see how that's very close to a 1.0? That's a very big area because the entire area equals 1. All of the area under this curve is 1. Look how close that is to 1. So that's pretty much as big as you can get. Pretty close. And then the small area comes from the 1.83 negative. 1.83 negative is 0.0336. See how that's very small compared to the other one? Subtract those. I got 9624 to my 4 decimal places. Okay, let's do the next one. 1.83 and 2.65. It's the same story. The big one, take away the medium-sized one. Okay, area big, take away area small. The big one comes from the data value farther to the right, so 2.65, 0.996. Done that one already. And then the 1.83, 0.9664. All right, now we just have to think about our answers, because it's one thing to plug into a chart and a calculator and then write an answer. It's another thing to understand it. Do you think a lot of people would fall between two standard deviations that way and that way? Do you think a lot of your data would lie in between two standard deviations that way and two standard deviations that way? A lot of your data would live there, right? Because what's outside of the general norm? These are anomalies, special cases, right? What do they call it in science? When you have like a bunch of data and then something over here, you draw a line of best fit and you just ignore that one? What is that? What do they call that? Outlier? Outlier. The stuff in the middle is the norm. The stuff on the outside are the outliers. Most people get close to the average, right? Then you got your high flyers, and then you got your low flyers. If it's heights, you have really, really short people, and you have really, really gigantic people. But most people are pretty much the similar height from boy and girl or whatever. This one. Look at how small this decimal is. What percentage of your data is going to be specifically between these two standard deviations? Are a lot of people going to fall directly into this little section? This is a very specific little section. That's why not a lot of data falls there. Okay, questions 1 to 3. We'll finish off this lesson tomorrow. And we'll do the quiz tomorrow.